Civil 3D Users Group meeting. Today, the title of the presentation is going to be Corridors and Divided Highways. Bill Newhauser is going to be doing the presentation for us today. He's going to be starting in a little bit. I'm just going to share with you some brief status update items regarding Civil 3D and our standards and training at Wisconsin DOT. So, we did have a recent training material update. You should have, if you're signed up on our distribution list, you should have received notification within the last week or so. And there's a couple items that went out over the last month that I wanted to bring to your attention. One of them is what we call a project data map, and that's found in our help document on the training website. So I'm on our website right now, and the help document that I'm referring to is this document that I'm pointing at right here. And within that document, you'll see it starts with a table of contents, and the project data workflow map is on page 29. And I've already loaded it up here. I'm not going to go through the entire map. I just wanted to bring it to everybody's attention. It's a completely new concept that we've developed in our training content. It goes through all the different objects, software objects that you'll find in Civil 3D, and it creates, or at least describes, some of the relationships between these objects. And the whole thing is based on our project directory structure and format. So different kinds of DWG files within your project data, where they go, what they should contain, how the referencing is happening between them. The project data map, this is our first iteration of it. I can see us using variations of this through a lot of the different types of material that we're presenting to you guys. So I can see detailed ones with real high level or real detail level referencing type of connections established. I can also see us having, a general overview type map, which is more of what this one is like. And maybe even eventually, live links to training content about some of these different object types and how they fit into our workflows and stuff like that. So it's our first iteration of it, but I can see it being a centerpiece of future communications and training. Some of the other new content that we have out there this time around, we have a workflow for beam guard end terminal grading, for developing the grading surfaces, for modeling the grading surface at our end terminals. We also have a workflow that shows people how to use super elevation controls to control daylight link slopes, believe it or not. It's not obviously the intended use of the super elevation controls, but it's a creative way of using the tools that we have available to help do complex things like slope transitions and some of the design model cleanup that would occur at the end of the design process. Also, we have an article on SSA. It's not detailed workflow. We're still working on that type of content, but it's more on the options and settings, making sure that you set yourself up correctly in SSA. So look to that content for the details. Some of the things that we're working on right now that we hope to be able to share in the near future. As you guys know, we have plan sheet examples in, I believe, chapter 15 of the FDM. Those examples are actually, most of them I think were generated from MicroStation using our older workflows, our MicroStation standards. There's some minor discrepancies aesthetically between our old plan sheet formats and the current plan sheet formats that we're generating out of Civil 3D. So we want to update those FDM examples with Civil 3D examples. We're in the process, we're working through that right now. And then just in general, the focus for our team has been training content development for the past several months, and it's going to continue to be a focus of our team for the next 6 months to a year, I would say. We have new workflows, new workflow ideas, best practices that we're trying to build into our training offerings. We also have content that's in the training already that's 5 years old now that is in need of update. And we're also presently working on a new distribution mechanism, a new management tool to manage our content that we're sharing with you guys. So it's going to allow us to publish in different formats and stuff like that. So these things will be released within the next 12 months or so, I would say, at Wisconsin DOT. So that's some of the things you could be looking forward to. So 11:15, I'm going to turn things over to Bill Newhauser, and he's going to be showing us divided highway corridors.
Okay, let me go ahead and show my screen here. Okay, can everybody see that? I'm assuming so. So I'll go ahead and get started here. First thing here, just a little bit more about myself. I'm Bill Newhauser. I'm a registered engineer in both North Dakota and Minnesota. I've been using Civil 3D pretty much since it came out, which for those that don't know, we've actually just had probably our 10-year anniversary for Civil 3D. I don't know what the exact date was, but so it's been out probably longer than Land Desktop had at the same time, so FYI. But so I've been using it pretty much since it first came out. I've worked for Managed Design out of Minneapolis here since 2005, so I'm coming up on my 10 years myself. So I've worked on the consulting side of life here for about 10 years before this, so I've done my fair share of divided highways, but using Land Desktop. I wish we'd have had the software about 15 years ago, but anyway, it is what it is. What I'm going to cover here today, I'm going to show you guys how to do divided highways using both the stock sub-assemblies that come with Civil 3D, and I'm going to show you guys how to use it using also one of the Wisconsin DOT supplied assemblies here. And then I'm going to show you guys a little bit here. I've got an intersection built with a median coming into it, and I'm going to show you how to do a bullnose, kind of quick and down and dirty. I won't get too much in depth in that, but just to show you guys that it can be done. So first things first here, we're going to come over here and look at the sub-assemblies. And the stock sub-assemblies that come with Civil 3D here, there's a couple different ones to look at here. Under medians here, we've got the median constant slope of barrier, median depression, shoulder extent, etc. Now these are a little more complex ones, okay? And then down below here, a lot of people don't know about this, but in the generic, we also have a couple here that will act the same way. It's these link slope, let me see right here, link to mark point and link to mark point 2. Now, also in this area is a sub-assembly called mark point. Now, this one here will need to be used both with the stock and also with the Wisconsin DOT sub-assembly. This is kind of the key to everything, and I'll talk a little more about that in a little bit here. Now, let me go up to the Wisconsin DOT assembly here, and in the categories, oh, a sec here. Where'd they go here? Okay, up here on top. Right here, we have this urban median. Now, I'm going to right-click on here and go to Help. And now, the one thing that on this one is that this sub-assembly, not only does it do the median portion, but it also does the core portion here too. So it has them both built into it. Now, if I go back out and look at the stock Civil 3D assemblies, they do not necessarily have curb. Now, some of these, if I go in and look at them, some of them, this one does not, but some of them has the shoulder portion of it. And let me show you one of those. I believe it is like this one here. If I go Help on this, you'll see this one not only includes the ditching in the middle part, but it also gives you somewhat of a shoulder sub-assembly here too, and a little more detailed information on it. Now, we won't go in depth on these, more or less just so you know that they're here. How you use them is pretty much the same between all of them. It's just the details are going to be the different on what they can actually do in the middle part. Now, obviously, this one here is doing a depression, so this would be more like an interstate type situation, to whereas the sub-assembly here for Wisconsin DOT, we go in here, This is going to be more of a urban situation here where you have curb. So this case here, so we have the median assembly. Now, I'm going to show you guys this one here in a little bit. But as we go down here, there is a lot of input parameters here that you can look at. Now, I'm also going to show you here, probably to me, the big thing on this one is that you have all the different types of curb and gutter pre-built. And now they got all these different types: A sloped, D sloped, G, K, L, R, T. Okay, and so I've got a little demo there to show you exactly what each one of these look like. And all this is really just a toggle. So if we change it, you can see here it's defaulting to the A type. So if we toggle to the L type, that subassembly here is going to be totally changed. Now they don't have a good example in here in the help showing what they all are. Well, I guess they do. Never mind. Down here in the bottom here, they show the different types. They don't show the real details on them, all the specifics here. But they do talk a little more about them down below here. Now, something here I'm also going to show you here at the very end here. I did, in the process here, find a couple little bugs that I want you guys to be aware of. And I'm going to have to probably work with the guys here to see if we can get these fixed because they're internal. And that some of these codes here aren't working properly. I found that out by pure accident. So I'll show you what I'm talking about when we get into it. Now, what I've got here, just to show you the difference between the two here, I made a corridor up here, and this particular corridor, just for demonstration purposes, I have a whole bunch of different regions, okay? And then each region I went through and I applied a different assembly here. Now, the one thing about these assemblies, and when you use them, they normally don't look anything like what they're going to look like for final presentation, okay? And what I mean by this is that we have the left side of the road over here, the right side of the road over here. Somewhere in between here, we're going to have a median, okay? But it's not going to look like what you're normally used to in your typical section. So don't worry that it doesn't look right here. Worry that it's going to look right when you actually use it. And so each one of these here, you can see there's nothing here in the median because what we've got here, if I click on it here, this is the actual, in this case, this is the median raised crown subassembly, and it's over here. Now, you'll notice how it's going to the right. Well, in reality, it should be going to the left. Well, it will, okay? What's going to happen here is that this subassembly is going to look for a marked point, okay? In this case, the marked point is a big triangle here, okay? And so it doesn't care if it's on the right side or the left side, it's going to go find it. And in this case, it's going to actually turn this around and aim back and connect the dot. Okay. The other thing here that I did on purpose is that these subassemblies, you'll notice here, now I'm using what they call an offset assembly here, which if I go up here to the home and I go under assemblies, it's this button here. Okay. Now, in order to use the offset assembly, you have to have a regular assembly in here first. So the process to creating these, we build the left side in this case first, okay, and then we drop in the offset assembly here second, okay. Now, you can do these with a normal type of a curb and gutter where you have the assembly running down the center line of the road, but I want to take this opportunity to show you guys how to use these offset assemblies. I know a lot of people don't understand them or see the need for them, but they do work quite well here in a divided road. Now, one of the big advantages to this is that this gives you the full power to apply a different profile to each side of the road. And so some cases here you may need to control the flow line on the left side independently from the right side for your design purposes. And this gives you that power, and it's a lot easier to use, quite honestly. Okay. And the other thing is too is that this will allow this center line to be able to go in and out independently, while the median is going to shrink and get bigger. Okay. We can also, which I'll show you in a little bit here too, is we can apply targets to like the curb here, actually the face of curb, cause this assembly to stretch inward, or in this case outward from this offset assembly. Okay, and that would be like a left turn lane, which I'll show you guys in a little bit here how that works. Okay, and you can also do the same thing on this side. So doing this, we have full control. We can still make both of these lanes go in and out independently following targets, okay, and that's still possible. Now, what I'm going to show you here eventually here too is doing an intersection. Now, using an intersection, that's going to force me to actually have your normal centerline alignments, okay? And so I wanted to do this because, you know, one thing about using the intersection tool, it can build intersections quite quickly. And so for large intersections, it's really nice to do it. So what I like to do is build the intersection first, then come back and fill in the regions in between from intersection to intersection. So I'll let the intersection figure out all the oddball stations for me, and then I'll fill in the gaps later on. And I'll show you that in a minute here too. But first of all here, what I want to show you here is how we actually create one of these. So what I'm going to do here, I'm going to first drop in create an assembly here. And I'll just give it a name here. I'll call it test. And I'm just going to drop it in here any random point. Okay. And then I'm going to go over here to the lanes, and I'm just going to go ahead and use the lane outside or lane super elevation AOR. And when I use this, it's going to give me a little warning here, which you'll see in a second here. But I'm going to pick on this. I'm going to look at the properties here. I want to make sure it's doing the left side, and that's fine. I'll take the defaults, drop it in. Okay, I'm going to change this to the right side. Okay, but the only difference is I want to change the default slope here from a -2 to +2. Okay, now if I left it as a -2, then we're going to have a crown on the left side and a crown on the right side. What I want to do is I want to mimic a crown down the center of the road. So I'm going to change this to a +2. Okay, and I'll come out here and drop this in. And then I'm going to now go in and drop in just a stock curb and verify left or right. Okay, I'll change this back to the left and drop it in. Okay, and change it back over to right. Drop it in. Okay. Now, what I want to do is I want to create the offset assembly here. So I'll come back up here, click Add Offset Assembly. Okay. Now, to add that, if you look at the command line here, the Add Offset Assembly. Okay, select an assembly or press Enter to select it from the list. I'm going to go ahead and just grip on this. Now, it doesn't matter where I put this. It could be some random point. It doesn't really care. So I don't have to be specifically over here at 42 feet and exactly at a 0 elevation, you know, a difference. I can pick some random point here. It doesn't care. Okay, so I drop that in. Okay, now at this time, what I'd like to do here is I want to add in the mark point. Okay, one thing to keep in mind here, that every one of these assemblies we're going to talk about here, they require a mark point. The mark point is going to give it the spot where it's going to lock back into, okay, the target per se. So it's going to connect from this right side to the left side, but it's going to seek out that mark point. So in our case here, the mark point is going to be right here, okay. So I'm going to come over here, go down to generic, click on mark point, and I'm just going to call it, actually I should be able to go to properties here, and under name here, change this to mark point. Oops. And uppercase, lowercase is very critical here, okay. And I'll go ahead and drop it in. Now, right now, because of the code set that I have turned on, you notice I don't have a circle to grab onto. So I'm just going to pick. Now, you'll notice I can't see anything. What I found here, if I go back into the subassembly, or the assembly, change my codes here to all codes, okay, that turns on all the circles, and now I can see this assembly, the mark point being turned on here, okay. Now the next step is I'm going to start building the rest of this. Since I've already got it over here, I'm just going to grip on these, right click, oops, I'll do it one at a time here. I'm going to copy to, oops, try that again here, Okay, and then I need to do the curb. Copy 2. And last but not least, copy 2. And drop it in. Now it didn't get right on, so I need to grip on it and move it up. Okay, I'm not going to worry about any daylighting on this for right now. No sense in muttering up the screen here any. So all I'm going to care about is just the main portion of the corridor here. Okay, so I'll go ahead and save the drawing here. Okay, now what I've done over here, I just have an alignment here, and I have an offset alignment. Now, what I have done here, I've offset this alignment 42 feet, because if you think about this, if this is going to be a typical median type of a section here, in my experience, so we got 24 feet of roadway here, okay, and 24 feet again on this side. So to get from this center line to this center line, okay, for the major portion of the road here, I'm going to have to come over here 12 feet plus 18 feet, which is typically from this face to this face, and then another 12 feet, okay? So that's 12 plus 18, so that's 30, and then we've got another 12, so it's 42 feet. So all I've done here, I've gripped on this, and I created an offset alignment, and I set that at 42 feet. Now, I'm not going to do it here because I've already done it, but I set that at 42, I set that at 0, and I click the OK button, and that created this offset alignment here. Then the next step was to go in and create a finished ground profile for each one of these, which I have done so down here. Now, just for simplicity, I just did a straight line grade from start elevation to the end elevation on both of these, so nothing real special about this. So they are not going to match, at least I don't think they will. So my elevation starting point here is a 95.54, and we got a 95.45. So I'm 3/10 difference between right side and left side, and that's fine. That's fine. That's one of the advantages to using this method, because again, you can control the right side and left side independently from each other if you want to. Okay, so now next step here, since I've got the alignments, I've got the profiles, and now I have the assembly here built. Oops, I'm missing one part. I'm missing the stock assembly to connect in between here. So what I'm going to do, I'm going to, in this case here, I'm going to go to medians, and I'm going to do median depressed here, which again, if we go to help here, it's just a simple, going to be a link down, ditch width over, and a link back up. So nothing real special here. Okay, so I'm going to go in here, grab this one, pick on this circle here, okay, and again it drops it over here. Now the next thing I have to do is come in here and go to subassembly properties, and I need to change the name here to match what we had used for our mark point. Okay, so real original mark point. Okay, now save again here. Okay, and now at this stage, I'm going to go into the corridor here. I'm going to create corridor. I'll call this one test. Okay, the alignment is going to be class, and the assembly is going to be my test, and target surface, e.g., I don't think it's going to really matter because I don't have any daylights anyway. Then I'll click. I'm going to leave this toggle on, set baseline and region parameters, because what I have to do next, since I'm using those offset assemblies, they need definition. Okay, so under here you'll see offset number 1. The alignment is nothing, so I'm going to go in here, change this to class right. Okay, and then I need to come over here on the profile and make sure that I'm going to be using the finished ground profile for the right side. Okay, and now I should be able to click OK. Go and hit rebuild, and there you go. Let me save again. Okay, so now if I grip on, go up here to section editor, and get it to run here. Okay, now FYI, when I do this, okay, it's using my my base class line, or BL class baseline, which is on the left side. So I have to zoom out to see it all. Now, one of the downfalls here is that with 14, if I go to the next station, it annoyingly pans me back in again. But you can see what's going on here. Now, since the right side and the left side do not match elevation-wise, you can see our ditch is now shifted off to the right a little bit. Okay, and really, that's about it. I mean, it's really the biggest thing here when using these sub-assemblies is that you got to make sure that you put the mark point in first. Okay, it has to do with programming. So if I go into the sub-assembly property or assembly properties here and go to construction, okay, you'll see this mark point. Okay, so as we started building this, it starts creating this list from top to bottom. Okay, so the mark point must be above, in this case, the median depression. See, this one's looking for a mark point because programming-wise, it's going to go from top to bottom. So the mark point doesn't do anything by itself, but when you get down to this one, this says, oh, I need to go back to mark point, which means it's up here. If the mark point was down below this, it would not work. Okay, and the only way you can really fix this, it would be to go out and delete both of these, redo them again, but this time put the mark point in the correct location. So do it first and then do this one second. There's no way to sort them here or anything. So, okay, so now what I've got over here, and this is part of the sample drawing that I've sent out. I've got all the different assemblies here. So link to mark point, link to mark point 2, link slope between points, urban median. Now this is the DOT one here. Then down here, raised medians, constant slope, median raised with crown, and then I've got all the different scenarios here with all the different curb types here for the Wisconsin DOT subassembly. Now, doing that, I go into the corridor properties here. All right. I can get on the corridor. Go to the parameters here. You'll see here I have the one baseline, but then it's busted up into all these different test sites, okay? Test regions, I guess you can call them. And you can see here they're all the same, except I'm using the different assemblies here, which are actually over here. Here's all the different types of assemblies here. Now, this other one that I have down below here, kick out of here. Okay, this corridor here, what I've done in this one is just to show you that it's something that you can do. Okay, this alignment here, I've got it running totally independent from this alignment. Okay, just to show you that it can work, but to show you what happens when you do this. Now, you notice that since we have the subassembly on this edge going to the left in this case, or going up, okay, this wants to stay perpendicular with this baseline, not with this baseline. So you can see how they come up here and how they don't necessarily match. Now, that's generally probably not going to be that big of a deal. Okay, even though these don't match, okay, if I was to turn on the tin surface right now and see the triangles here, and maybe go to a finer resolution on the contours, you might get a little weirdness happening here, but it's not going to be a whole lot. Now, things you can do to help alleviate some of these problems is that if you go into the surface here, the corridor surface, there might be times when you want to add in feature lines as data types in here. Okay, so the way this works is normally we add in at the very minimum the top link and the datum link for the top surface and the datum surface. Okay, and that's good and great. That will work most of the time. But when we start curving things, that's when it might be important to come in here and add in these other links. Okay, these feature lines essentially here. Okay, now what's going to happen here? These links here, okay, the top link and the datum link, that is these lines here, these brown lines you kind of see here. Okay, these feature lines, these are going to be the cyan, the magenta lines going along with the road. So if these are the back of curb, the flow line, the top of curb, the edge of travel way, that type of stuff. Okay. Now, think of these as brake lines. Okay, so these are brake lines going this direction. Now, when I toggle this on, this tells them to treat them as truly as brake lines. And just to let you know, this can come back to haunt you, so FYI. I've got them toggled on here just to try to get the surface nice and kosher as possible. Okay. Now these, when you add these are treated pretty much like brake lines. Okay, but longitudinal wise. So this is going to assume that I want all the back of curbs here to be connected. Now, if you don't do this, you can run into times when, if you have a real tight, maybe like a left turn line, it doesn't quite match up correctly, and you'll see the curb will be kind of real stepped looking. I'll show you in a minute here what I'm talking about here. But this is how we cure that situation here. Now I'm going to jump over to another drawing a little bit here where I've got a little more detail on this. But again, things to think about here. Okay. Now, one thing I have learned though is that you can run into a situation is that sometimes if this offset assembly is too far away, so if I grip on this and I drag this way out, okay, what will happen here, or what sometimes does happen, it didn't look like it happened here yet, but sometimes what will happen is these lines don't go far enough, okay, and they'll be stuck way out here, be really short. It doesn't seem to affect anything, but just so you guys know that it's stuff that can happen. It's more of a cosmetic issue, okay? Now, let's go up and look at the actual cross sections here. And what we've got here, that's kind of hard to show you exactly. Let's zoom in on these. Now, most of these here, the only real difference here is that the curb is going to be differently here, okay? Now, when you do this, you got to make sure that in your corridor, and this is really critical in this one, you got to make sure that you have the overhang corrections turned on. Okay, the top links and bottom links, especially the bottom links. Okay, if you don't, it's going to get real weird in here. This yellow line here, this is my datum surface. Okay, if I had that turned off, it'd probably go up and come back down and come back over here, and it just does not look right at all. Okay, so you've got to make sure that stuff's toggled on. But beyond that, everything looks pretty good. Okay, I don't know if there's much difference in the curb there, but here we got a totally different curb type here. And again, there's not much really to talk about here. They are what they are. Okay, now let me switch over now. How much time we got here? We've got about 17 minutes here. Okay, I'm going to switch over to this other drawing that I've got, and you guys have access to this drawing here too. Okay, now this one, I'm taking everything that we knew or know here about using these assemblies for doing the medians, and then what I'm doing, I'm building the intersection here too. So if I go in and look at this in 3D, and FYI, if I ever get blown out of Civil 3D, this is when I do it. So hopefully I don't. I have to take baby steps, I found. Okay. So here is an intersection here, and you can see the bull nose here, and we got left turn lanes. Now, this is the part I was talking about here earlier. Now, I did mention to you guys earlier I found a little bit of bug in the stock subassembly. Well, that bug is causing this to occur, okay? And I'll explain to you in a minute here what I'm talking about here. But that's where it's happening here. It's happening in this area right here. If I go turn on the tin, you'll see what I'm talking about here. So turn on triangles here. Okay, right now these cyan lines, okay, they should not be interpolating to this point. They should be running along that magenta line, which essentially is the flow line. Okay, but the problem is the stock subassembly here. If I come over to it, go to help, okay, all the way down here in the coding diagram, P1, P2, 3.3, 3A, and P4. Okay, each one of those has a specific code attached to it. If I go up here and look, P3 and P3A are top curb, median left, top curb, median right, and then P2 is also this, and P1 is this here. Okay. Okay. What I have to do, or at least I attempted to do, but it didn't work, and I kind of told you guys about this earlier, is that if I go into the corridor surface here and go into the top surface, okay, I'm using those codes here, and it should theoretically be connecting the dots here, okay, but the stock assembly here is ignoring these. So I have no way of looking inside the programming on here, but something's not quite right. Now, this could be as simple as that particular curb type that I used. If I toggle it to a different curb type, who knows, it might work. You got to keep in mind there's a lot of programming going on in the background you guys can't see. So it's very easy that a couple of links were not coded correctly. But again, we'll be talking to the DOT about this more in depth later. Maybe they can fix it in the future here. But you can see here, here's the surface that I've got created here. I've got a top surface and a datum surface. Okay, here's my top surface. Now you'll notice I have this set to no display because I'm creating a composite surface right now where I'm taking the existing ground and I'm pasting my top surface onto it. So if I turn this back off, oops, go back in here, change it back to, okay, so as you see there, if I grip on this, this is including not just existing ground, but also through the road here. So I have a composite surface working here, okay? Now, one of the things I found here that seems kind of weird, and I'm not sure what's really causing it. I don't know if it's the, I don't think it's the Wisconsin DOT stock subassembly that's causing this. I think there's something embedded in Civil 3D that's causing this problem. But I've put in a left turn lane. Now all I've done here, and I might be able to grip on it here. Let me change my display order here. Is underneath here somewhere, at least there was, there is a pollen line that I drew in, and I'm using that as a target. You can see this one out here. Okay, there's another one here. I just can't get on it. It's in the background here. But I've got a pollen line that's going along the face of curb, or I guess the edge of travel way here, and it goes along from here up, coming down to here, and then it stops here, and then I've manually drawn in bullnose. Okay, and also in the same scenario over on this side. Now we probably all know that Civil 3D does not do bullnoses very well or very easy, and there is no way of really automating this process within this intersection. Okay, so actually what I've got going on here, I've used the intersection tool to build this portion of it, and this is just using stock assemblies here, nothing really special here. If I was going to 3D and look at this, this is just the standard shoulder, I believe, over here. Nothing special. I mean, this takes literally, what, a minute and a half to create. Okay. Now, this portion through here is just a normal corridor coming into here. Now, this is all one corridor. So what I've done here, I've built the intersection first, and then I turn around and I merged, or I should say, I added in this portion into that corridor. So if I go and look at it here, you'll see here that I have, this is the, I grip on here, you'll see the regions here pop up. So this is region 1 and this is region 2, which is over on the other side of the intersection, okay? And then down below here, this is all the intersection baselines. Now, these were created using just the corridor or the intersection creation tool, okay? Nothing real special here. Now, what I had to do though, a little retrofitting here, because when you use the intersection tool, you have to have an alignment going down the center line and the center line. Well, my alignments are going along the center line of this road, and you can see it here, the center line of this road. Okay, and so the fun begins is trying to get these two to match at the critical, at the match line here, which in this case is right here. Okay, because there is no reason to try to make the corridor build all the way through this intersection because it just can't do it, okay? And it cannot do the bowl nose. Now, the bowl nose that you see here, all this is a bunch of feature lines. This outer feature line is draped on top of the top surface of the corridor, okay? These other feature lines are just using the stepped offset command, okay? I've got access here to some third-party stuff here. I don't know if I can't even get on it here. You probably can't see it, but I can't because I've got my little menu bar on top of this. But I've got a little third-party app here that I pick on this outside, and bam, it automatically builds all these for me automatically. So this takes me about 2 seconds to create, okay? But if you have to create these manually, again, all this is, I drew a polyline where the face of curb is going to be. I threw in, I believe it was a 5-foot radius here. I came back, okay, and then I turned around, and actually that line, since I'm in a curve, came from this alignment here. So I offset this over 12 feet, then I offset it over, I think, 12 plus 5, 17 feet, okay? Then I did some trimming here, did some good old AutoCAD commands here. I created this outside line, and then using the feature line tool, you can convert that into a feature line, drape it onto the top surface, and then turn around and offset it. You know, the different, you know, if you go look at the assembly here, and I believe, where did I put it here? Right here. What I did here, I drew a polyline along this, and I went from node to node to node to node, and that's what you see here. So then on a separate piece of paper, I figured out what the offsets and the elevation differences were. Okay, a little tedious, but again, using that third-party tool, it wasn't that big of a deal. Okay, but if you have to do this manually here, you need to figure out what the offset and elevation difference is, and then when you create these other feature lines, that's all I'm doing here. Now, once these are feature lines, then all you do is you add these to your surface as break lines. Now, I added these to my composite surface. I did not add these to the original top surface coming from the corridor. I wanted to keep that untouched, okay? And so if I come over here and look at my corridor surface, or my composite surface here, under definitions, okay, I have it right here. I call it curb south and curb north. So curb south essentially is basically all these feature lines. Curb north are the other feature lines. Now you can do this exactly the same thing if you happen to have a pork chop out here, maybe a little island. Now if I had had a right turn lane coming in here, I very easily could have had a little island stuck out here, okay? And so by drawing that in, draping it onto my top surface, and then using the feature line tool, I could create the other feature lines. Now, the beautiful part is when you do this, this is what you get for your cross sections here. If I can find them here. Okay, so this is our median coming in, and as I get over here, this is where we hit our left turn lane here. Okay, this is somewhere in here. This is station 3, station 7. I'm sorry, station 7 here. So that's right here, and then over here, which is going to be, I believe, down here, we have station 750, still median. And then right here at 767, okay, I just cut one through here just to show what it looks like, okay. This is what it's going to look like, okay. So all I really care about here, quite honestly, is the two surfaces, the top surface and the datum surface. Yes, the corridor is continuing on through here, okay. This method does not clean this up. There's no real easy way of doing this. There are other methods out there that I've seen where people will run an alignment right along this and back and over here and do some fancy footwork, and it will actually make it look a little bit better. In my opinion, it's a little more harder to manage though. This is just down and dirty, but this is what you end up getting. And because of the you know, I actually took the time to figure out the offsets and elevations. My curve actually looks pretty darn good here, okay? And then the other thing I tried to do here, I tried to match what was occurring back here. So you can see these other feature lines here that were occurring. Now this is coming from the stock subassembly. And so I didn't match this center line because I didn't really know what that one was. So it might be a little flat here. I don't know if it's supposed to be intended to be a little higher peak. Now, if I go look at this in 3D on the corridor, and also on these subassemblies here, this is what you get. And again, this is where this is where things get dangerous here. Our presentation might be ending sooner than it should, but this is what it looks like in 3D. It looks like I got a little burp happening here, which I can go back and fix, but I'm not sure what happened there. It must have been something with the surface that was trying to daylight. But again, this is why we draw in 3D too, right? Okay. Now, one other thing I noticed, and I'm not sure what was causing it, is for some reason I was getting this in the curb returns. I'm getting one oddball curb return here that it wants to stretch it all the way out here for some reason. The fix for this was to come over here. You can see it right here. The fix that I found for this was to grip on the corridor, take that region, and just move it a little far away. I mean, I'm just creating a little gap there. And you might have to move it, might have to keep fudging it a little bit here to get it to work. But usually when I did, you can see how it disappeared. Okay, so again, I'm not really sure what's happening there. Usually the intersection tool is pretty good about those. It's kind of a flashback to 2010 or so. See, I have another one here. It'd be the same thing. If I grip on this, move it over a little bit. It doesn't seem to hurt anything, but I'm picky, so I like to make sure things are cleared up. I'm adding just a teeny tiny gap there. It's not going to affect anything. And there it cleans it up. So now, again here, now the one, before I'll close it out here real quick like here, the one thing I found too, and again, I'm not sure why this was occurring. Normally, if you're doing like a left turn lane or right turn lane in a corridor, okay, I should be able to just draw this pawl line from here back up around and stop it and do this for every single intersection, and I should not have to draw this pawl line running along here, okay, because my stock assembly, okay, the full section, okay, says that this is what it's supposed to look like. Well, the problem I had is that if I had not done that, in fact, I'll go ahead and I'll show you where that's at. If I go into this second region and I go to my targets and my width target here, okay, if I remove this pawl line right here, which I'll go ahead and do so, all of a sudden I lose all my curve on both sides. And I don't know why. It should not be doing that. And it wasn't doing that until I added in this pawl line. If I remove this pawl line from the equation, then it's good. Okay, so again, under normal circumstances, that should not occur. So if I go back in here again, corridor properties, I go into that region, go over here to targets, in here, select from drawing, click on it, click OK, 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 and now it's back again. Okay, again, I can't explain what's going on there, but the good news is there's a workaround. So, okay, well, I'll go ahead and I'll call quits on my end here. I'm going to look at the chat session here. I see here we got a couple comments here. Let me go look up through here. Okay, I don't see them on the list here. Yeah, if you guys got some questions here, now's the time to go ahead and put them in the chat area, and I'll see if I can answer them for you. Who can type the fastest? I can hear the typer.
Hey, Bill, Brad Hollister here.
Yes.
Yeah. As we're waiting for comment or for questions to roll in, I'd like to just have a couple comments on what
Sure.
you showed today.
Sure.
So a few quick ones here. One of them was you mentioned the curb types. If you look at our standard detail drawings in our facilities development manual, you'll see the actual, in much greater detail with the dimensions, the curbs that are built into our subassemblies. Another one, you mentioned some subassembly problems with our curbs. One of the problems that's out there, it's just in our 2014 package, but when you put certain combination of curb types with other input parameter entries together, sometimes the thing bombs out on you. We just recently fixed that, and so you'll be looking for a new subassembly library to be distributed in our next standards update. We've been sending those things out monthly.
Okay.
The third one is I noticed you were using stock subassemblies, and by that I mean Autodesk subassemblies alongside with Wisconsin DOT subassemblies. That's great. That's what we intended. We had built our library to be supplemental to what Autodesk already offers, and what general practice we've seen is a lot of people use our subassemblies and then they'll supplement with some of the stock ones. There is one gotcha if you're going to use a mixed design with Wisconsin DOT and Autodesk subassemblies, and it's with the subassemblies that use super elevation control. So we developed our library before axis of rotation functionality existed in Civil 3D subassemblies. So we don't have that functionality built into our subassemblies. So the super elevation comes off the baseline alignment, and all your subassemblies for that alignment should either be, well, I should say all the subassemblies that use super elevation for that alignment should either be all Wisconsin DOT or all Autodesk. And it's because the Wisconsin DOT subassemblies are not built for the axis of rotation controls.
Okay. Good to know.
Another one I'd like to comment on, it was really great to see the workflow you put together. The offset assembly usage is something we haven't promoted in our training, in our workflows. Early on, and this goes back to the 2010 version, whenever we used offset assemblies, we were having troubles with the corridor surface recognizing the feature lines that we had assigned to it. So it was the problem that we were seeing with your curb, where those feature lines weren't being used to define the surface. We were seeing those types of problems anytime we used offset assemblies. Now, at the time, I thought we had tried the Autodesk version of subassemblies and had the same problems, but that was 4 years ago. I don't remember for sure anymore. But we steered away from the offset assembly usage for that reason, because our corridor surfaces need to be feature line based, and the feature line definitions weren't carrying into the corridor surfaces in the areas where we were using offset assemblies.
Okay, that might explain that issue I had there on that left turn lane.
Yeah, that's kind of what I was thinking too. And that problem could be within our subassemblies as well. It could be something that was maybe addressed with the stock subassemblies. Again, it's been 4 years and we haven't gone back and looked to see if it worked. If you're wondering out there, you can do the exact same things that Bill was doing workflow-wise, just adding another baseline instead of using the offset assembly. That's been our workaround, and it's so effective and it's so easy. It's really no more effort either way. We just haven't gone back to the offset assemblies since the initial bad experiences that we were having. The last one is use of links in the corridor surface definitions themselves. We've been doing a lot of discussion internally here about that. We currently have been stating it's bad practice to use the links in our corridor surface definition, and this one will take about a minute to explain too. What you have to realize is one of our deliverables with our design model packages is the longitudinal break lines in the roadway designs. And the primary source of those longitudinal break lines for our proposed surfaces is from the corridor. So one thing that's kind of a safety, or I guess I'll call it a quality control mechanism within our workflow, is if we're not using the links to define our corridor surfaces and we are using the feature lines to define our corridor surfaces, we're much more likely to use all the correct feature lines to build that corridor surface. If we're using the links in addition to the feature lines, then there's a chance that we might forget to add a feature line, but the link is making the surface look good anyway, so that when we go to extract out our longitudinal break lines, it'd be really easy to forget one or two. But if we're not using the links and we're just using the corridor feature lines, if we forget one of those feature lines, we're going to see it in the surface right away. There's going to be a discrepancy between what we're seeing from corridor graphics and what we're seeing in the surface, especially in that corridor section editor. So, you know, that's one reason why we've been steering away from the links. Another one is the overhang correction. And it's because overhang correction is using link definition to re-establish surface triangulation differently than if you had just used the feature lines alone. It's causing a discrepancy between the location of the longitudinal break lines, which are our corridor feature lines, and the surface and what it's doing. And so what we recommend people doing, we do have some of those problems, especially with our curb subassemblies and some of the other subassemblies that have vertical or near vertical link components to them. We use just a generic link and we create an additional corridor feature line, maybe 1/100 of a foot offset from the vertical, either on the top or on the bottom, and then we use that one that's offset 1/100 of a foot in our surface definition, rather than using the default corridor feature line link that the subassembly creates. Okay, so in other words, yeah, go ahead, Bill.
Well, I say, okay, so what you're saying there is that, okay, if we use the links and we use that the correction, the top link and bottom link correction factor, that throws in that vertical line up, it connects in with your horizontal link, whatever it might be. So you're saying the workaround of that is to drop in a generic link from this point up at a slight angle to a specific spot up here, what you're saying then.
Yeah, actually what I would have you do is connect it to the top corridor point or corridor feature line.
Okay.
So that vertical link has a point on the top and a point on the bottom. If you connect the generic link to the top one and then you just put it at the same slope as your terrace, but you put it 1/100 of a foot to the right,
okay,
then you can use that one.
Okay, so you're drawing a line. You're basically doing a link out here, and then you're coming down. Is that correct?
I'm sorry, Bill. Could you say it again?
So you're having a generic link from this, going from, like, say, the back of curb out, just a hair past, and then you're drawing another one from that point down to here.
Yeah, you know, our sub-assemblies create the behind the curb area a little bit different than the stock ones do. So, you know, our sub-assemblies build a terrace across the top, and it includes the top of curb. It starts at the top of curb, but it extends through past our subgrade cutout all the way out to a terrace point.
Yeah, here's the stock one right here. But
here, I'm just gonna.
Yeah, go ahead.
It's not working. I'm not able to navigate or anything anyway.
Okay. Well, anyway, we can talk about that everybody here on the side here too, to kind of but I see what you're getting at. So the bottom line is, instead of, so if I go back into my corridor surface here, and I go to my surfaces here, okay, one, we are not using the links. So I'd remove this from the list. Okay, I remove this one from the list. I'm not going to do it just because I don't know what the other links are supposed to be yet. So you're going to have the surface built off of everything else here. But but now if I go ahead and click OK, and I'm doing this just so everybody out there can better see what will happen here. Oh, it didn't update. Oh, I still have the Oh, I've got the corrections kicking in here. So this is what will happen. Okay.
Yep.
So he's trying to explain how we cure that problem, so everybody knows.
Yeah, so I'm not sure what subassembly created this, but our subassemblies would typically have a vertical component that extends.
Well, this is the stock one that came from you guys. This is your median. But you're saying you're still going to have to go in here and add in a generic link in here manually to get this to work.
Yeah, except we'll add it. You see the vertical component for your base material there? With our subassemblies, that same vertical link extends all the way up to the top.
Okay, it comes all the way up.
Yeah, and we'll attach to that top point there, and we'll just go 1/100 of a foot to the right. And we'll use that one in the datum surface definition, rather than the one that the subassembly created, which might have that vertical problem.
Is there a separate setting within? Because this is the this is the assembly that's being used right now. So it's the urban median.
Yeah, maybe it's your code set style. Maybe some of the links are turned off. I don't know.
Yeah, that could
Some
be.
of the links and points. If you go to the help file just hit the help file once. That'll show what I'm talking about, and then go to the coding diagrams at the bottom.
Oh, what must be on it? No, it's generic link. What is that a generic link for?
Okay. Look at there was a,
If you go to the,
it's on the left.
No, I'm on the whole assembly, or the individual sub here. Just a sec here. Oh, my computer is taking its time.
Bill, if you go back to that help file, we actually have all the subassemblies in that one HTML package.
Oh, right here. Okay, right
Yeah,
here.
in the tree view on the left there.
Uh,
Go to barriers and curb.
right there. Okay, there we go. Okay, so you're saying this link right here?
Yeah, well, if you see that second diagram?
Yeah, a little. Well, that one's connecting to. Oh, right here. This diagram right here is what you're saying.
Let's go to the code diagrams on the bottom, maybe. I thought that point was on this subassembly. Maybe it's not, huh?
P14.
Yes.
P14. So P14 is going to be datum left, curb, datum right.
Yeah, so we just connect to that, go over 1/100 of a foot, and use the one that's jogged over a little bit in our surface definition.
Okay. Okay. Well, again, we could talk about this on the side here, but I think it's good for everybody to see that, though, because you know what? That brings up a good point, because I remember the last presentation, the person I think had done what you're saying, and then everybody else around here, I think most of our consultants went, well, why are you doing that when you can just do that toggle? So I think this is good. Explain to everybody why you guys do it that way, because the problem you guys have run into. So,
Yeah, and there's other areas where using the links in the surface definition does add value. It can positively affect triangulation of your surface, especially like in the intersections with those curb fillet regions, for example. When it gets transition between the main road and the side road, some of that triangulation occurs across, in a perpendicular direction to the way we want to see it.
yes.
So we're working on some workflow concepts that would allow us to use the links and without overhang correction, still be in good shape, but we're still not settled on that. So right now our recommendation is just not to use the links at all.
Okay. Yeah, because the intersections here, if you don't use the links, they can get kind of really weird.
Yeah.
I'll show you here. They might do it now. Yeah. See, it doesn't do this area.
Yeah, so what we'll do, instead of using the links, you got, okay, see your curb, corridor feature lines, your curb corridor feature lines aren't in the surface definition. So when you take the links out of the surface definition, that's why it's ignoring a bunch of stuff.
Yeah. See, if I was to go back in here and add the links and turn them as break lines, then that cures that. But then you run into other issues.
Well, yeah, I mean, what we would rather see is use all those additional corridor feature lines to define the surface rather than the links.
Yeah, but the problem is though, you need you need it somehow to connect these lines in this direction. And right now, you're running basically feature lines along this line, along this line, along that line. But unless you're going to actually do manual break lines, it doesn't know that it should be going in this direction necessarily. That's why you're ending up with those big holes.
Yeah, so what we'll do is we'll add one single break line from the center of the curb radius, from the flange to the center of the curb radius to that junction point between the main. And we'll do that in the refinement surface, and that will redirect all that triangulation to the direction that you want to see.
Right, right. Nothing's perfect, right?
Oh yeah, well, you know, that's the thing about Civil 3D. There's so many different ways to approach things. There's so many different workflow variations, and for us, it's partly, you know, the way we're defining our deliverables that drive some of these decisions. That's
I understand. I understand. All right.
You know, and
any of those questions popping up there? Okay.
Anybody in the room here want to ask something?
And keep in mind here too, my original intent here is just more or less to show you guys how these assemblies can start working. I want to do an intersection here just to kind of use up some more time, more than anything else. But I think the big thing to take from this is just remember is that mark point has to come first. If you don't do that, they won't work. But they are very flexible otherwise. Well, we'll go ahead and close down on our end here. Everything good?
Yeah, Bill, we're doing great here in Green Bay. I really appreciate the presentation you put together today, and I know we had a lot of people here today that benefited from it, so thank you.
Yeah, we got a lot of people here too, so we got a good crowd. Okay, well, thank you guys, and Merry Christmas and have a Happy New Year and safe travels to everybody. We'll go ahead and shut it down.